Hang tight. All right, guys, we are learning about two of the new formulas today. So I told you there's going to be 6 altogether for this chapter. We've done one, simple interest, which is the easiest of all of them. And then today we are looking at compound interest. Do you guys remember simple interest we talked about yesterday? Like you put money in once and that money sits there and like every year you earn the same amount of interest on it, right? Because it only builds on what you initially put in. Compound interest takes all the interest you've earned, puts it on top, and then you have a new balance that it earns on, so then it earns more. Puts that money on top, the next year it's going to earn even more, so it keeps building. So if you can get compound interest, that's the type you want. All right, so compound interest, it's money earned on the money deposited plus previous interest. So it keeps building, so every year you're going to make more and more and more and more. So it's definitely the route you always want to take. And then just so you have it in your notes there for comparison, for simple interest, only the original principal is used to compute the annual interest. Simple interest, same amount every year, never going to change. Compound interest, you make more. How often does that interest get added on to the principal? Do you guys know? Is it once a year? Once a month? Once a day? Once an hour? What? It is. It's on how you set up the account. Yeah, interest can be compounded different ways. And you're going to have to make sure you know these numbers. Interest can be compounded annually. So how many times a year is annually? That's once, one time a year. Okay, so if it's annually, it's just one time per year. By the time that year ends, they'll take all the interest you've earned, they'll put it on top, and then that's the new balance that you'll be working on to build interest off of. Semi-annual, how many times is that? That is 2 times. Every time I hear that word, I always think of Victoria's Secret semi-annual sale, right? It's twice a year. Help you remember that. Quarterly, that is 4 times per year. I always think of how many quarters are in $1. How many quarters make $1? 4, right? So quarterly, 4 quarters in $1. There are 4 times per year. And then daily. How many days in a year? 365. So that means every day the amount of interest you earn gets added on, and then that's your new balance that keeps getting added onto. One other one I forgot to put on here is monthly, which would be 12 times per year. One other one that might show up, you may want to add it in here because it could show up in an example. It would also be weekly. See how many weeks are in a year? There's 52. I think there might be about all the different types of ways they might throw that at you. Yeah. All right. So we're also going to talk about the annual percentage rate and the annual percentage yield, APR and APY. Have you guys heard of those two terms before? You've probably seen them on bank things, right? The APR or the APY, and you're like, I don't know what that is. Okay. Annual percentage rate is the interest rate paid or charged per year. So if you get a loan, are they paying you or charging you? If you get a loan, are they going to pay you interest for taking their loan? They're going to charge you interest. Right, so when you get a loan, so you go out buy a new car, they're going to charge you like 4% interest. That's how much interest per year they are charging you, 4% of the value that you borrowed. Okay, or interest rate paid, if I get a savings account, that's the interest they're going to pay me on all the money that's in there. So you got to kind of think both ways with that one. And then annual percentage yield. want to make sure you understand what this is, because this is one of your other formulas, is APY. It's the simple interest rate that would be required to give the same dollar amount of interest that the compounding gave. So, compounding takes the money and keeps adding it on, adding it on, adding it on. So you're making more and more and more every year. Well, what simple interest rate would you need to have in order to make the same amount of money over that same amount of time? Obviously, it's going to have to be higher. Right? The higher, it is higher than your APR for accounts that are compounded more than once. So it's going to have to be a higher rate so that you actually make the same amount of money in the same amount of time. And that's one of the things people always compare. The higher the APY, the faster you earn money. Okay? So the simple interest rate that would be required to give the same dollar amount of interest that the compounding gave. Higher than APR for accounts compounded more than once. Do any of you have a loan right now for anything? Lonnie? Why are you laughing? Uh-oh. Do you have a loan, Travis? What do you have a loan for? Car? A truck? Do you know what your APR is? Like, what's your interest rate that they're charging you for that loan? Do you know? 8%? Ooh, that's high. Lonnie, do you have a car loan as well? Probably what? You don't recall the percent? It's one of the things you guys definitely want to look at when you do go to get your first car loan to buy a vehicle, is shop around for your rates. Okay? 8% makes me cringe. That's high. Okay? I know I purchased, obviously if you purchase a new vehicle, sometimes you can get 0%, which means they're not charging you any interest. You are literally paying for the vehicle, and that is it. So that's good. I know I bought a vehicle once. It was newer, maybe a year old or something. I paid 0.9% interest. The older the vehicle you buy, the higher the rate they charge you, because it's not new. It's not worth as much. So if you buy a vehicle too old, they won't even give you a loan for it anymore. So if it's too old. Right now, I think our vehicle, we bought a 2012 3 years ago. So it was 2016. So it's 4 years old when we bought it. I think our interest rate was 4.5%, something like that. So just shop around, though. Different banks have different rates. Okay, so here's your first formula for today. Isn't that beautiful? That's nothing compared to some we're going to see later on next week. Oh yeah, that's nothing compared to next week's. This is your compound interest formula. Okay, a couple things you need to make sure you make note of. This is equaling B, which is your ending balance. Simple interest, let's kind of compare this as we go. So your simple interest formula, do you remember what that one was? I equals PRT. So what did the I stand for on that? What did the I stand for? Interest. Simple interest formula solved for the interest. So if you wanted to know your ending balance, you had to take the interest and add it back on, right? In the activity you guys did yesterday, you had to really read carefully if it wanted the total balance at the end or just the interest part. It made a difference. That formula solved for the interest. This formula solves for the ending balance. So if I wanted to know the interest here, I'd have to subtract off my original amount so I could see what the difference is. So they solve for different things, and it's so important you guys remember that, okay? This one solves for the ending balance, not the interest. P is still your principal or the original balance, just like it was in that one. R, still the interest rate as a decimal, same as that one. N, that's a different variable. You didn't have that before. It is the number of times compounded annually. So if it was monthly, you'd put a 12 there. If it was weekly, you'd put a 52. Okay, does that make sense? It's how many times it's being compounded. Jaden, you with me, hon? Everybody's so tired today. Are you sick? You like that automatic? Your eye is puffy? Just one? I mean, okay. Is it both eyes or one eye? I can't look at it. Sorry. You just looked like you were like completely out of it right there. All right, and then T is number of years, just like the simple interest formula. Okay, so the only thing different is we have an N, number of times compounded per year, and then this one solves for the ending balance as opposed to the interest. Okay. All right, so number 1, Marie deposits $1,650 for 3 years at 3% interest compounded daily. What is her ending balance? Okay, so we want to solve for the ending balance. Now, right now we only have the 2 formulas, right? We have simple interest, and now we have this compound formula. You have to know when to use each formula. Simple interest, the only time you use that one is if the problem says what? Simple interest. If it doesn't say simple interest, you don't use it. Somebody's going to use it. That's going to drive me crazy. All right? Probably. Well, just tell you now, stop it. I'm going to throw my pen at you if you use it, okay? Right? He's been born. I'm going to throw my pen at you. Okay. So we know this one's compounded formula because it literally says the word compounded right in the formula, okay? So I have a formula written right over there. So we're going to plug everything in. Not senior scripted? Thank you. You're so sweet. And a tardy slip. That's great. He's right. I'm already mad. Okay, so here we go. So we're going to plug stuff in. We don't know the ending balance. That's what we're solving for. The principal, the initial amount, is $1,650. Parenthesis, and there's a 1, plus the R, 3% would be written how? Good, 0.03, divided by the N. If it is compounded daily, how many times a year is that? 365. And then notice the top, it's N times T. Well, we just said my N was 365. And T is how many years? Said 3 years. Okay, so the hardest thing about this formula, and actually all the formulas from here on out, is people being able to actually type them in. You can use a regular scientific calculator, but you have to be good with parentheses. And I find students make way more mistakes with those than if you use these. Because these, you can literally see the entire equation the way you wrote it. Do you know what I mean? It'll look the same. So the scientific ones you can do, but there's a lot of parentheses involved. So let's go ahead and type this one in. So 1650, parenthesis, 1 plus, do you guys know where the fraction button is on these? If you hit the green button, so hit the green alpha button, and then hit y equals, it's literally 2 buttons above that, and then hit enter. That puts up your little fraction like that. So green, y equals, hit enter, puts up your fraction, then you can type that in, 0.03 over 365. When you go to close your parenthesis, though, make sure you arrow out of the denominator, right? You have to hit the right arrow key to arrow out of that. And then do you guys know where the exponent button is? The exponent, yeah, exponents, that is the little caret button. It's called a caret. Looks almost like a little triangle. It's at the bottom. And then the caret button's above divide. All right, so you'll do 365 and then times 3. So again, you can see your equation should look just like you wrote it, which is really nice, helps you kind of notice things. All right, so go ahead and double check yours. You should get an answer of $1,805.38. So what you should get. If you did not, let me know and I'll come try to help you figure out what you did wrong. Good. Need help? All right, guys, let's take a look then at number 2. Kate deposits $2,350 in an account that earns interest at a rate of 3.1% compounded monthly. Again, you've got to notice these key words. Once I have 6 formulas, you have to tell which one's which. So that's the hardest part of that. What is her ending balance after 5 years? Round to the nearest cent. Okay? So I know it's the compounding formula, so I'm going to go to this one. I don't know the balance. My principal is $23.50. 1 plus R is my percentage rate. So what is 3.1%? What would you write? 0.031. There you go. Divided by the N, if it's compounded monthly, how many times is that? That is 12. And then my exponent is N, which is 12, times T, and it says it was 5 years. All right. So again, just practice typing that in. So 2350, parentheses, 1 plus. The 1 is part of the formula. Yep, just part of it. Yeah, just part of the formula. Somebody way smarter than I am figured that out. Should get $2,743.45, rounding to the nearest cent. And you can bet your bottom dollar I'm going to take off a point every time you don't round correctly. You should know by now that I'm going to take off those points. Uh-oh. You have a random parenthesis in there. That's what's causing the problem. Yep. If they take that parenthesis out, you should be okay. Sure you can. I'll show you in just a minute. So you see the DEL right there? You can just hit delete. I'll take it out. There you go. To bring that equation out, if you just arrow up and highlight it and then hit enter, it'll bring it back so you can actually do stuff with it. Oh yeah, never lazy mathematician here. I'm going to do less work. All right, anyone have trouble getting that? Guys, please make sure you're trying every problem, okay, so we can get the calculator down. All right, number 3. Riley invested $13,482 at 2.6% compounded hourly for 6 years. What is her ending balance? How much interest did she earn? Right here is where people get stupid and they go to use the simple interest formula because they see the word interest. Does it say simple interest? No, so don't use that formula. It's only simple interest. You go to that other formula. All right, so if I'm looking at this one, I'm seeing the word compounded, so I know it's my compounding formula. All right, so here we go. So B equals my principal, $13,482. 1 plus the rate, 2.6%. It's 0.026. Oh, it is compounded hourly. How many hours are in a year? Well, how many hours are in a day? There's 24 in a day. There's 24 hours in a day. How many days are in a year? 365. Yep. So to figure out hours in a year, you just multiply how many hours, how many days we have, right? So that's going to be 8,760. And then 8,760 times how many years? 6 years. Yes. Yeah. All right, so let's go ahead and find our ending balance. So 13,482 times 1 plus, put in your fraction, 0.026 over 8,760. Close parenthesis, and then make sure you have an exponent. 8,760 times 6. After 6 years, they would have $15,758.11. All right, so that is finding her ending balance. And the question also asks how much interest did she earn. Do not change formulas. Do not. It does not say simple interest. If I know the ending balance and I know what she started with, just subtract them. That's the interest she earned. All right, so to find her interest, you literally just take what she just earned, $15,758.11, and subtract what she started with, $13,482. I think too often we get caught up trying to use a formula for everything that we kind of lose our common sense. So $2,276.11. I mean, think about how money works. If you leave money in a bank and it earns interest, so I'm going to make more at the end of the time I'm looking at, right? So how did I get from what I started with to what I ended with? How did I earn that? What is that called? That's it. That's interest, right? That's your interest. The money that you earned over that time is all the interest that you earned. Questions there? When do I use simple interest formula? When it's a simple interest, not just interest. All right, you just had to subtract those every day. All right, so the other formula for today is the APY, or your annual percentage yield. So again, this would be the interest rate needed to earn the same amount with simple interest as you do with compound interest over the same amount of time. This is a really, really easy formula to tell when to use it because it literally will ask you to find the APY. It's the only time you use this formula. So again, the R is your interest rate as a decimal, N is the number of times per year. Notice there's no T in here, nothing like that. All right, so Sharon deposits $8,000 in a one-year CD at 3.2% interest compounded daily. What is Sharon's annual percentage yield to the nearest hundredth of a percent? So again, it is asking for the APY. So we will use the APY formula. Yes? So does the 8,000 actually get used in this formula? I lost my APY. There it goes. No, the 8,000, it's irrelevant. So as I'm plugging stuff in, just fill in your formula because it says what is the APY, so I know I use the APY formula. 1 plus the rate is 3.2%, so 0.032 over N. How many times is it compounded? Daily, which is 365. N is the exponent, 365, and then minus 1. So the fact that I'm depositing $8,000, it's irrelevant. It's not using the formula. How many zeros are in 100? Yeah, so anytime they ask you like 100,000th or whatever, think of that number and how many zeros there are. So that's how many spots you want. All right, so let's go ahead and try this one in the calculator. So make sure you have your parentheses, 1 plus, and then use your fraction button. The rate, 0.032 over 365, close parenthesis, exponent of 365. Make sure you arrow down out of your exponent because your cursor sits up top. Hit the arrow so it drops it back down, and then your minus 1. And it should give you 0.0325. I'll kind of stop there for right now. Does that mean it's like 0.03? Is that the answer I'm looking for? That's as a decimal, right? So how do I change that to a percentage? If you just multiply that by 100, some of you can do that obviously just looking at it, but if you need to, you just multiply by 100. That's going to give you 3.25%. Remember what I told you before, the APY will always be higher than your APR. Your percentage is always going to be higher to get the same amount with simple interest as it would with compound. So it is a little bit higher. Not necessarily. I mean, they're somewhat close. I mean, they're not going to be like percentages huge apart. All right, anyone have trouble with that? Okay. Number 5. Barbara deposits $3,000 in a 1-year CD at 4.1% interest compounded daily. What is the APY to the nearest hundredth of a percent? Again, it's easy to tell what formula because it literally says APY in it. All right. So APY equals 1 plus, my rate would be 0.041. It is compounded daily again, so 365. 365 is my exponent, and then minus 1. All right, so go ahead and type that in. Should give you 0.041897, blah, 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 on. Again, in your calculator, if you're more comfortable, as soon as you get that, multiply by 100. Because we need to change it back to a percent. Then it's going to be 4 point, what would you round it to? It wants the nearest hundredth, which is 2 decimal spots. So it's 4.18%. Because it was 1, 8. What did I write down? This should have been a 4. Sorry, I wrote down the wrong number on mine. Sorry. It's 497. I lost a digit when I wrote that. Sorry. That's why you were confused. Yeah. Yes. All right. That's APY. Easy formula. This chapter's not bad as long as you know what formula to use. But if you use the wrong formula, that's all wrong. Yes, thank you. You got to read correctly. And yesterday on the activity we didn't hear, not all of you read correctly. Right? If it asked for interest versus it asked for the ending balance. Now the formula compound, what does that solve for? It solves for the balance, the ending balance. But if I wanted the interest, you have to subtract off the principal, right, to get that interest in there. Okay, we will go ahead and stop right there.